Okay, hello, welcome back. This is 5-4, day 2 notes, so still working with coordinate geometry. Okay, so the first part here says graph each polygon with the given vertices, which means corners, and give the most specific name for that polygon. All right, so we're going to go ahead and plot all of these points and label them. So C is at -4, 7, which is going to be up here. And then we have point D, which is at 6, 7. E is at 6, -3. And then F is at -4, +3. Okay, I'm going to connect these using a straight edge here. Okay, so this is a quadrilateral. It's got 4 sides. And what's special about it? Does it look like a square, a rectangle? No, it doesn't look like any of those. We do have 2 right angles, but the other 2 are not. So I do see here that side CF is a vertical line, and that has undefined slope. And then I also see that DE is a vertical line, and that has undefined slope. So segment CF is parallel to segment DE. That's probably the most special thing about this quadrilateral. And I don't know if it would help if I turn this for you, because a lot of times when we look at this shape, we see it this way with the parallel sides on the top and the bottom. That's called a trapezoid when you have exactly one pair of parallel sides. Okay, the next one has coordinates -3, +1. That's L. M is at 0, 1. N is at 1 and -4. And then Q is at -5, -4. Okay, so here we have another quadrilateral, and just by looking at this, this looks very similar to this one in that I see here a horizontal line and here we have a horizontal line. So in this one, segment LM is parallel to segment QN, but LQ has a positive slope and MN does not. So those are not parallel. So this one again is going to be a trapezoid. Okay, be on the lookout for shapes that are squares or rectangles or parallelograms, because those would pop up possibly. Okay, so the next one says triangle RST has a right angle at S, and segment ST is 3. Find a set of possible coordinates for T. So now there's actually multiple solutions for this problem. There's 2 different solutions. It says here that RST, it's going to be a triangle, so I have one segment here. There's a right angle at S. So right here I'm going to have a right angle. So we need to find where T could be. So T is going to have to be somewhere along this line that I have set up so we can have a right angle. And the distance from S to T is going to be 3 units. So if I count that on the graph, 1, 2, 3. Just want to make sure that it's a little hard to see on this where the grid is. Okay, so there's one possible triangle that I could make. The coordinates there are at 4, 2. Okay. I could have also drawn my right angle on this side, and I could have gone 3 units to the left as well. So 1, 2, 3. Here's where T could also land at -2, +2. Now, when you give your answers, all you need to give is one for a problem like this. You don't have to give both possible solutions because it just says find a set of possible coordinates for t. Okay, the next one says quadrilateral JKLM is a square. Find the coordinates of M. So we have J, K, and L here. So to be a square, all the sides have to be equal in length, and we have to have all right angles. So if I look at how long these sides are here, it's 1, 2, 3 units long. This one is also 1, 2, 3 units long. The only place that makes sense to have the other coordinate is here. Okay, and it also needs to be noted that when it gives you the name of a polygon, that the letters go in that order as we're going around the polygon. So it has to be J, K, L, and then the M has to be over here. We kind of go in a circle, either clockwise or counterclockwise when we're naming it. So this point right here is 3 units away from L, and it also is 3 units away from J, and it makes that square. So in this case, here's point M, and the location there would be at -3, -2. That's the only possible location for this problem. Okay, the next one says find possible coordinates of the missing vertex. So this one we're looking for a parallelogram, and they give us 3 of the vertices, and we're looking for the 4th. So A is at -3, -1. C is at -1, -4. And D is at -4, -4. Okay, so now here's the thing. Again, I just told you that the order of the letters is important because in order to have a parallelogram, if the order of the letters didn't matter, I technically could put a vertex up here somewhere, or I could put one out over here, or I could put one down here. But since B comes in between A and C, that means the B has to be out over here somewhere. Okay, in order to figure that out, I'm going to look down here. In a parallelogram, the opposite sides are parallel and equal in length. So here, DC has a length of 3. So if I do the same thing here, I go up here from A and I mark this as a length of 3. Here is where point B is going to land. So B has to be at 0, -1. Okay? Now you're going to notice here that since it's a parallelogram, the opposite sides are also going to have the same slope. So here from D to A, we're going up 3 and over 1, and here from C to B, we're going up 3 and over 1. Okay. So again, B is at 0, -1 is the only possible solution for this parallelogram. All right, here we want an isosceles triangle, which means 2 of the sides are the same length. So J is at 2, -1, and then K is at 5, -4. And they want a right angle at L. Okay, so they want a right angle wherever point L is. And I see that in order to make a right angle with the triangles, I either need to come up over here to make a right angle or down here with a right angle. Now with triangle JKL, I could call this JKL this way, name it counterclockwise. And L would have a right angle. Or I could name this JKL, naming it clockwise, and put point L down over here. And it would still have a right angle at the vertex L. Okay, so this one has 2 possible solutions. And when it says find possible coordinates, that means find all of them. Okay, if it says find a set, you only need to put one, but in this case, we're looking for all of them. So here down at the bottom, this one could be 2, -4. Or we could use this one over here, which is at 5, -1. Okay. Now, isosceles, just to point out, means two of the sides are the same length. So in this blue triangle down here, this leg of 3 is the same length as that leg of 3. And over here, this leg of 3 is the same length as that leg of 3. So they are isosceles right triangles. All right, last page here. It says on Saturday, Nguyen and his family visited the Lincoln Memorial, which we're going to call point L, the Washington Monument, W, the White House, H, and the National Academy of Sciences, which we're going to call point N. And here are the coordinates for each site. Graph and label them, connect the vertices, and give the most specific name for the polygon formed. All right, so the first one is L is at -4, +2. I'm sorry, let's do W next. W is at 2, 2. Then we have H at 2, 6. And N is at -3, 3.5. So -3 and 3.5 is going to be about here. Okay, so here is my polygon. It has 4 sides, which makes it a quadrilateral. Are there anything special about this quadrilateral? Well, I don't see any opposite sides that are parallel. So the answer to this one is no, there's really nothing special about it. So this one is just going to be called a quadrilateral. That's the most specific name we can give it. Okay, the next one says the White House, the Washington Memorial, and the Smithsonian form triangle HWS. So we have H and W here, we just don't have point S yet. It says triangle HWS has a right angle at W, and WS is 3.5 units. What are some possible coordinates of the Smithsonian? So again, H and W are making a triangle, and I want it to be a right triangle. So I could draw the third leg to the side this way or to the left to get that right triangle. Okay, so one of the ways is I could start at W, and it's 3.5 units, so 1, 2, 3.5. This would form a right triangle here. Or I could also go 3.5 units to the left of W, and I would still have a right triangle. So it's possible that S could be here or here, and we just have to write those coordinates out. So this one is at 5.5, 2. Or the other one here is at -1.5, 2. Okay. The last one says the Department of the Interior is located at the midpoint of the White House and the Lincoln Memorial. What are the coordinates where the Department of the Interior are located? Okay, so the White House and the Lincoln Memorial, we just want the midpoint of those 2 points. So if I look back up here, the White House is H, right? The White House is H. So that's going to be coordinates 2, 6. And then the Lincoln Memorial is L, and L is at point -4, 2. So I'm going to use my midpoint formula that we learned in the last lesson. And the midpoint formula, If you remember, we add the x coordinates and we divide by 2, and then we add the y coordinates and divide by 2. Okay, so going up to these coordinates, my x coordinates are 2 and -4. So I'm going to do the -4 plus the 2. It doesn't matter which order I put those in, because when I add, either way, it's the same thing. And now my y coordinates are 2 and 6. And now I have to simplify that. Okay, so this one, -4 plus 2, that's a -2. And -2 over 2 is a -1. The next one, 2 plus 6 is 8. 8 divided by 2 is 4. So that would be where the Department of the Interior is located. And I could kind of look at that here. -1, 4 would be right in the middle of the Lincoln Memorial and the H. Okay, this line isn't drawn. I'm not gonna, oops, I'm sorry. -1, 4 is right in the middle of the Lincoln Memorial and the White House H. And we didn't draw that line in there, so I'm not gonna draw it in there to muddy up the picture, but -1, 4 definitely does look halfway between the L and the H. Okay, please let me know if you have any questions on the coordinate geometry.